Hello everyone, I am Andreas Delig and I'll be introducing our topic, graphical methods for lenses. So this topic will help us understand how lenses form images using ray diagrams. First, we have the graphical method. So it is a simple way to locate where an image will appear when light passes through a lens. So we do this by drawing a special line called principal rays. And it's almost the same method used for mirrors, but at this time, it's for lenses like the ones in our cameras or even sa atong eyeglasses. No? So there are three important rays that we use to find the image. First, we have a ray that goes parallel to the axis. So it will pass through or appear to come from the focal point. Second, a ray that passes through the center of the lens. It will basically go straight without bending. And the third, a ray that goes through the focal point will come out parallel to the axis. So by drawing these three rays, we can find where the image is located. So why do we use this method? Of course, we use this to easily see what kind of image is formed. If it's the real or virtual, upright or inverted, or even bigger or smaller. So, ano siya? So basically, this concept is also used in optical devices like kanang cameras or kanang sa itong laboratories, kanang microscopes, or even kanang eyeglasses. Lastly, keep in mind that principal rays are not the only rays that can form an image, but they're the easiest ones to use when drawing. So they help us find the image's position quickly and clearly.
So good day, everyone. Now let's move on to the laws and principles of the lenses, and we'll start about the two main types of the lenses, which are the convex and the concave lens. So a convex lens is also called converging lens because it makes light rays meet at one point and it's thicker in the middle, while the concave lens is a diverging lens, meaning it spread out the light rays and it's thinner in the middle. So in short, convex lenses focus light while concave lenses spread it out. Next, let's talk about the three main rays we use in ray diagrams. So the ray 1 goes parallel to the axis and then passes through the focus of F, so as you can see here in the diagram. And the ray 2 passes through the center of the lens and continues straight without bending. And ray 3 passes through F first, then comes out parallel to the axis. So these three helps us find where the image will form and what it will look like. So for the conversion of convex lens, the image changes depending on where the object is placed. If the object is beyond 2f, the image is real, inverted, and smaller. At 2f, it's real, inverted, and same size. So between f and 2f, it's real, inverted, and bigger. And when the object is inside f, the image becomes virtual, upright, and bigger. So that means a convex lens can form both real and virtual images. Now, lastly, the diverging or concave lens. So it's simpler. No matter where the object is placed, the image is always virtual, upright, and smaller. So this happens because the rays spread out but they look like they're coming from one point behind the lens. So concave lenses always form smaller and virtual images.
Hello everyone! For my part, I'll explain how to find where an image forms when light passes through a lens. We'll be using two methods, the graphical method and the mathematical method. So first, we start with the graphical method. We draw the lens and principal axis, so you can choose whether concave and convex lenses. Then draw the principal axis. This is the main horizontal line that passes through the center of the lens. As you can see, the line that is in the middle, that is the principal axis. It helps us determine where the light rays go. Next, we mark the focal points of both sides of the lens. So focal points are those in blue dots. It is found in both sides of the lens. These are labeled then as f1 and f2. Then we draw the three principal rays. First ray, draw a ray parallel to the principal axis. After it passes through a convex lens, it goes through the focal point. But if it's a concave lens, the ray appears to come from the focal point. Second ray. This ray passes straight through the center of the lens without bending. Then finally, the third ray passes through the focal point before reaching the lens and comes out parallel to the axis. Where the rays meet or appear to meet, that's where the image is formed. From there, we can describe if the image is real or virtual, upright or inverted, and bigger or smaller than the object. Next, we use the mathematical method to check our graphical result. We use the lens formula, which is 1 over f equals 1 over s plus 1 over s prime, where f is the focal length, s is the object distance, and s prime is the image distance. For example, we have a convex lens with a focal length of 10 centimeters and the object is 20 centimeters away. Again, we use the same formula, which is 1 over f equals 1 over s plus 1 over s prime. So we substitute the given values. Now we have 1 over 10 equals 1 over 20 plus 1 over s prime. Now we solve for 1 over s prime. 1 over s prime is equal to 1 over 10 minus 1 over 20. So the value of 1 over 10 is 0.1, while 1 over 20 is 0.05. So we subtract that and we get 0.05. Therefore, s prime equal 1 over 0.5 is equals to 20 centimeters. The image is formed 20 centimeters on the other side of the lens. Since S prime is positive, the image is real, inverted, and the same size as the object because the object is placed at 2f. Now for a concave lens with a focal length of 10 centimeters or negative 10 centimeters rather, and the object is 15 centimeters away. Again, we use the same formula, which is 1 over f equals 1 over s plus 1 over s prime. So, 1 over s prime equals 1 over negative 10 equals minus 1 over 15, which is negative 0.1 minus 0.0667, which equals to negative 0.1667. Therefore, s prime is equal to 1 over negative 0.1667, which equals to negative 6 centimeters. Since s prime is negative, the image is virtual, upright, and smaller than the object. The image is formed on the same side of the object as well. To summarize, a convex or converging lens has a positive focal length and usually forms real and inverted images, while a concave or diverging lens has a negative focal length and always forms virtual, upright, and smaller images. That's all. Thank you for listening.
So, good day everyone. To summarize everything, basically this method is used para malocate nato asa ma-form ang image when light passes through a lens. So, instead of using formulas or solving equation, we use light rays to show it visually. So, in short, it's more on drawing or illustration para mas klaro. So, now, even though daghan kayo og light rays nga mo pass through a lens, kailangan lang ta og two rays to find the exact image position. Pero usually, sa mga diagrams, we draw three main rays kay para mas easy i-understand kung asa ma-meet ang rays and asa ang image ma-form. So next, let's talk about the two types of lenses again. So first, we have the convex lens, which is the one that thicker ang sa center. So it can form either a real or a virtual image. So for example, if ang object is layo siya sa atong lens, ang image kay mo form on the opposite side and tinod siya is real, meaning the light rays actually meet there. Pero if ang object is duol sa lens, like sulod sa focal point niya, ang image mahimo siyang virtual. And mura din siya naa siya sa likod sa lens if imong tanawon. Then, we have the concave lens. So, kani concave lens is kato ni siyang thinner ang sa middle. So, this one always form a virtual image. So, no matter asa nimo ibutang nga object, virtual image gud ang iyang gina-show. So, ang rays ani is mag-spread out or mag-diverge. So, kung imo siyang i-trace backward, mura din siyang mag-meet behind sa lens. So, mao nang virtual gihapon ang iyang gaka-show. And just a reminder, any light ray can go through the image point. But for simplicity, we just use the three main or common rays nga makita nato sa diagram. So, for the next slide, here you'll see an image showing both convex and concave lenses. So, para ma-compare nato ilang shape kung unsaon nila pag-bend. So, here ang convex mirror is pa-outward and curved while ang concave is pa-inward. So, mo po na reason nga no, lahi ilang image formation kay ang ilang structure palandan is lahi na sila daan. So, in conclusion, the graphical method really helps us understand how lenses form images in a simple and visual way. So, by just using a few light rays, we can already see how the image forms and whether it's real or virtual. Convex and concave lenses may look similar, but they bend light differently and create different kinds of images. So overall, this topic reminds us that light and lenses work together to form the images we see every day. So that's it for our reporting, and thank you for listening.